languages which were really meant to be designed and developed for one platform and trying to use them on other ones. JavaScript is the one that certainly comes to mind because browsers are ubiquitous. There rarely is a piece of technology that can't run JavaScript. And so just aside from browsers, the frameworks that web developers use tend to get dragged along once JavaScript is executed on a platform. And so React and React Native are the ones that immediately come to mind. React is interesting because it takes a paradigm and kind of abstracts away the things that make a platform interesting and unique and tries to paper over them, allowing you to just focus on the actual business logic and UI of your code and have the framework deal with interacting, the complexities of interacting with things like the native toolkit. The problems here is that JavaScript really wasn't meant to run on these devices, and the language of JavaScript is actually fairly complex to run in a performant manner, something we'll take a look at. But the advantages here are huge. You have the ability, because JavaScript's dynamic and the runtime interprets the actual source code, you have the ability to do things like update your app, update the JavaScript in your app. Not even while restarting it, you can actually do this while it's still running. The way this works, React Native specifically on Android, is they actually embed their own JavaScript engine called JavaScript Core. It's part of WebKit's native library. And then React Native takes care of talking to this native library over JNI. It deals with things like the main thread and then interacts with Android's UI toolkit for you. On iOS, JavaScript Core is actually built into the platform. And iOS code runs natively, so they don't have anything like JNI where they have to cross this big bridge. And so they're just inside the runtime and again, talking to iOS's main thread and iOS's UI toolkit. And then on the web, you have the normal JavaScript engine, which is in Chrome V8, which talks to the DOM and renders the elements. And so JavaScript becomes sort of the baseline here, and then the platform-specific integrations allow you to leverage the UI toolkits of each platform, trying to achieve what is otherwise the holy grail of write once, run everywhere. React Native is sort of just a way to get our feet wet in these cross-platform frameworks, but you don't actually have to use something like that. JavaScript itself can be used directly as a way of doing code sharing. And so if we don't think about the actual integrations with the UI, V8 JavaScript is intrinsic to the web. It's always there. On iOS, JavaScript Core is embedded as part of the operating system, so it's always there and able to be leveraged. And then on Android, you can kind of do this with WebView, but you really don't want to. But you can always bring your own JavaScript engine. On Android, Chrome is a multi-platform product and actually runs on Android. They actually embed the V8 engine in Chrome, so that's something you could do in your app if you wanted to. And then when I worked at Square, we adapted this thing called the duct tape engine. The reason is that both JavaScript Core and V8 are fairly large and comprehensive runtime. Duct tape's actually rather small. It's about 200 kilobytes. So if you have the need to do this, it lowers the barrier of entry greatly, and certainly the impact that it has on your app. But the biggest downside of doing something like this is that you have to write code that talks to the code that's running JavaScript from your native platform, if you're not doing something like React Native. And so interaction from the native language can be problematic. And especially if you just interact with it directly, it has a tendency to leak into the rest of your code base, and then you become really coupled to it, and a lot of the benefits, the perceived benefits, become actually downsides. And so the easiest way to mitigate this is through abstraction. What you can do is actually take all that code that does the interaction with the cross-platform solution and hide it behind an idiomatic API. And what's nice about this is it's actually the same thing that React Native is doing. It's just doing the opposite. It's abstracting away the platform, and you're writing just common code. But if you want to still leverage something like JavaScript across multiple platforms, you really need to be doing the opposite, which is abstracting away the common code so that you get the nice idiomatic cross-platform API. And this way you don't inflict pain upwards through your layers of abstraction to developers. They really just interact with this as if it were any other library, regardless of whatever platform it's running on. And so JavaScript has talked about this a lot, like I said, because of its ubiquity, and also from efforts like React Native. Kotlin is an obvious one to talk about next, but I want to stop over on Swift first. Swift can actually compile to Android. Compiles down to native code. This was added to Swift about two and a half years ago now. And so it doesn't run in the managed virtual machine like our Java or Kotlin would. It turns into native code. So it can run next to like where you would have C or C++ otherwise. And if you're going to do Swift as a potential cross-platform solution, which is something reasonable to do, you wouldn't want to do it everywhere. You would want to do that same trick where you abstract it away. This is a really easy way to just take some code that your iOS team has already written, especially if it's business logic and well tested, that you can just kind of essentially steal it for free and get this nice, what is essentially library written in the language that you work in, and not even have to know that there's native code behind the scenes. The web, can you use that Swift code on the web? Well, the answer is no, but the answer is no, not because why you think it is. We're actually going to come back to that. And so Kotlin is, a particular favorite of mine, and it's a language which started as targeting Java bytecode for the JVM. JetBrains, actually the community quickly realized that it could be used on Android and pushed JetBrains to support it, which they very quickly did. And then eventually the idea of using it to target JavaScript or native came later. But with that, they took a slightly different approach than other languages. Unlike what you would do with something like JavaScript or Swift, Kotlin has a notion of platform-dependent and platform-independent code. And so today when you're writing Kotlin, you're likely writing platform-dependent code where you can reference things like JDK types, Android types. If you write platform-specific Kotlin for JavaScript, you can reference types that are present in the browser, like from the DOM. And if you write platform-specific native code, you can reference code that's available in native libraries. And when Kotlin wanted to do multi-platform, they came up with this concept called platform-independent Kotlin. We usually just call it common Kotlin code, where you actually don't have access to any of that. And it works similar to, if you've heard of like partial classes, maybe from C#, where the common code can really only reference common code and other common libraries. And then it has to be adapted to platform-specific Kotlin, and then eventually compiled for that platform. And so what's nice about this is you can write your Kotlin common code in Kotlin, write your platform-specific Kotlin code, or potentially platform-specific, Java, C, or JavaScript to perform that adapting to the platform. And then the consuming side can be written in any of the native languages intrinsic to wherever you're targeting. So you could write something and have your JavaScript, your web people consume this with like a library. And so then it would just be JavaScript or TypeScript. You can write this as like turn it into a jar, and then Android developers or server developers just consume it as a library. Or with Kotlin native, you can turn it into a native binary and just have your C or C++ code consume it as a native library. And so you still want to use the same multi-platform abstraction technique where you hide it behind, a nice idiomatic API, but the language is much more enabling here, where it allows you to, it's more aware of the fact that it has the ability to run on multiple platforms. And of course, you don't have to do this heavyweight abstraction if your whole app is encompassing all these things. You can just put them all in one project and have them be modules. So I've talked about the ways that we can leverage the languages that are intrinsic to the platform across multiple platforms. There's sort of an elephant in the room here where you would think that there's something else that I'm going to mention. And it came out of Google. It's a set of cross-platform tools. It's used by some teams at Google for code sharing and to really accelerate how they can build their apps. It uses a programming language that's hard for me to recommend. And in the past, I've been very critical of it on a technical level. And my views on that are really unchanged. If you don't know what I'm talking about, I'm of course talking about J2MC and Google Web Toolkit. If you don't know what these are, I don't know why we never see these presented at conferences, although I guess Kevin, wherever Kevin is, tends to talk about this sometimes. It's a transpiler for Java source code that allows you to run Java on iOS through J2MC and the web through Google Web Toolkit. And what's really cool about this as being a source transpiler is that entire libraries written in Java can survive through this. So if you have your Arch Java, protocol buffers or whatever, just pure Java library, you have it at the source code, it can actually survive this cross compilation. You can leverage those libraries on the web, leverage them for your native code, and obviously still leverage them for Java. And I tend to think the reason we don't hear about this is because, well, we're the Android developers and we're the ones using Java, and so we don't really care what these other teams are doing with our code. If you go to a JavaScript engineer on the web and say, hey, I'm going to reuse your code on Android, they're really not going to care because they don't have to change things, and that was us as Android developers. And so we don't really hear about this, at least until Kotlin started becoming a thing. And if you have teams that were doing this, Kotlin throws a wrench into this system, and you have to potentially look at something else. And so there are other multi-platform frameworks, like the one that I, again, just tried trolling people into thinking I was going to talk about. But I don't really want to talk about them here. I want to move on because I really don't want to spend, I wasn't trying to spend a lot of time talking about how to do multi-platform from the technical level. I actually want to change gears a little bit and talk about a little bit more conceptual things before we bring it back to technical. How many people have seen this photo before? Not many people. Wow, that's surprising. I guess it is a few years ago that this came out. It was a studio complaining about all the different devices that they have to test their app on Android. There was a survey done in 2015 by OpenSignal about sort of the shape of mobile platforms. And they put up this chart, which is all the device sizes that you would have to target if you were building an app on Android. And this is in 2015. That was Android. This is iOS. And what they said was the iOS ecosystem makes for good comparison with Android, as it's much easier to design for the considerably smaller number of dimensions. Now, when I read this, I think, wow, that's a really flawed way of thinking. There was no image for the web, though. It was just Android and iOS, which are the two platforms you tend to compare because they're the mobile platforms. But again, we forget about the web. So let's try and build our own screen size chart for what the web looks like. So I started with my browser, and that's the size of my browser. And then I drew rectangles for every other browser size that's out there. Because it's infinite, right? Like the web can be any size. And when you compare this to Android, this was 2015. So we're before multi-window, we're before picture-in-picture, we're before the freeform desktop Android was a thing. So really Android is like this as well. There's infinite screen sizes. There's no real exact screen sizes anymore. And then you bring up iOS again, which has changed a little bit, to be fair. But we tend to lump Android and iOS together when really we should be lumping Android and the web together because, at least from a design perspective, they are essentially the same, infinite screen sizes, and you need to change how you think about it. At WWDC this year, which was a couple weeks ago at this point, so macOS 12 is going to come out this year, and next year is macOS 13. They actually announced that you'll be able to take devices, you'll be able to take apps written for iOS and run them on the desktop now. Now, there's not a whole lot of details about that, but we can assume that they will exist in the same free-form mode that apps today on desktop exist, which means in about a year, iOS is going to have the same problem. Now, to their credit, there has been a paradigm shift from more pixel perfect to more responsive on iOS, so hopefully this is less of a problem. And as Android developers, I hope that we've seen things like this before. I stole these from material design. But if you think about design in terms of not screen sizes, but things like buckets, it becomes a whole lot easier, right? And this is how you think about this is usually how you think about the web as well. And then within the system of buckets, we have flexible let's say, columns that give us freedom to differentiate, not differentiate, freedom to actually ignore the differences between things like, a 720 pixel wide and a 768 pixel wide device. And then beyond that, we have the concept of things like breakpoints, where as you reach certain sizes, your app dynamically adjusts to the available space. And content that would otherwise be present on the screen moves off screen, but is still available via an affordance and still in the same logical location. Material design covers this, but really there's tons of design systems that behave this way. And since the web, we've determined that the web from a design perspective is a superset of mobile. Mobile is really trending towards this, this way where there's infinite number of screen sizes. You really need to think about this in terms of every platform, not just for web. All right, I want to shift to operating systems real quick. The Chromebook is a really interesting piece of what can be done with an operating system. It's a Linux-based OS, but Chrome is essentially like the windowing manager. And then two developments recently is that the Play Store is available for Chromebooks now. This is really interesting. There used to be something called Arc, which was sort of a simulator for Android. It wasn't very accurate. And then you didn't hear anything for about a year or 2 years. And what happened was the teams at Google were actually rewriting how this works. And so now it's completely different. And in theory, because this has this Google Play, it can pass CTS. And CTS is the test suite that sort of validates how Android behaves. And if that means that a laptop can essentially validate itself as an Android device. And the way this works is that the Android framework is running natively in a container on this Linux host, all the way down through the hardware abstraction layer, where it actually talks to the native hardware of the device. So like when you ask for the display, you get the display of the device. When you ask for Wi-Fi, you get the Wi-Fi of the Chromebook. This is very different than how we think of like the emulator running on our machines, where everything is abstracted away, it's emulated. This is Android running natively on this system. But then this year's I/O, we got Android Studio and other Linux apps running. And this is also done using the same trick, which is putting them in a container and where they can, interact natively with the device and also like consume your battery. But when you put these into comparison, there's three systems in play here. There's the original Chrome one, there's the Android one, and there's the Linux native apps one. And they're all solved with containers. They're all solved with this abstraction, but they're interacting natively with this shared host. And so I'm going to come back to the point that I'm making here. So this is the way that Android has sort of been brought to laptops in a more native way. And I want to change gears again before kind of circling back and tying all these things together and talk about the web coming closer to native on Android. This was announced last year at Google I/O, which is Instant Apps. The idea that clicking on a link anywhere on the web can trigger an on-demand install of an app and allowing you to use it right away. And so the way this works is that you have your app and you would generate like a fat APK that has everything inside of it. And that's what a user would normally install from Play. But you also create these smaller APKs, one which has the common code of your app, and then ones potentially for each feature inside the app. And so as the user clicks on a URL, these smaller APKs instead of the one large one is very quickly downloaded, installed, and launched as a replacement for what would otherwise be browsing to a web, downloading the web page, and running it. But if you think about it, this is a very similar model to how the web already behaves. We go to a link. That link resolves to some content. Content is downloaded. It's then run, interpreted, and then displayed. And just like the web, instant apps aren't installed. They are cached. So if you click a link once, the small APKs will be downloaded and launched, navigate somewhere else, and then navigate back. It won't actually have to re-download. The same is true of the web, right? There's like caching. You visit a resource once and it's going to be cached for a certain period of time. And so there's a strong parallel to be drawn to how the web behaves here. This is done with native apps. This is native apps behaving much more like the web. And you can upgrade to a full installation from this instant apps, which is similar to what you can do on something like a Chromebook. When you visit a web page, you can upgrade to a Chrome app, which is like an installed version of that web page. This year at I/O, there was sort of a revision of instant apps, or the technology behind it, which is app bundles, where the idea is instead of creating an APK for each one of these modules and features, we actually break them up into their component parts. And so each one of these has a DEX, which is the code that we want to run. There's maybe native code for a couple architectures, and then languages for each of the locales. And now what happens if we want to install this app in a traditional manner, where we otherwise would have that fat APK that had everything inside of it. If you do this through Google Play, it will on demand create a large APK, but that doesn't have everything inside of it. That's tailored for the specific device onto which you're installing it. And then later, if you do something like change your locale, change your language, it can on demand download only the additional bits that are needed, load them in, restart the app. If you're not installing the full APK and you're doing something similar to what Instant Apps is doing, you can actually only download not only the part of the app that you care about, but only the parts of that part that are relevant to your device. So if you're running this on a mobile phone set to English, and you only care about that one feature, you could download this really tiny APK. And then as you navigate throughout the app and reach other features, they can be downloaded on the fly. And again, this looks very similar to how the web behaves, right? We make a request to a web server. It determines what resources it needs to send us, determines what language it should be showing us based on things like the accept language header. And so this is now Google Play doing something very similar to that. Now, unfortunately, app bundles actually don't play well with instant apps. They're two separate concepts that are in similar spirit. And if you look at the documentation, thankfully, the team apparently is going to reconcile this and allow the much smaller app bundles to be used in the context that instant apps are, which is you navigate to a URL and you want that tiniest bundle to be downloaded on the fly. Okay. This is sort of the opposite view of instant apps, where we were taking something which was supposed to be the web and on the fly replacing something behind the scenes that actually made it a native app. On Android, you can actually do the opposite through Chrome, where you can add either a web page can prompt you to install the web page as a native app, or you can do it manually, which is done here through the overflow menu, where I'm taking this really useful app that plays an air horn sound and installing it as a native app. And you can see that it actually puts, not only does it put an icon on the launcher, but it actually is a native APK that you can drag into settings and see that it is a real APK. This is something called Web APKs on Android. It's a feature of Chrome, but it's not specific to Chrome. It's actually something that's a larger endeavor on the web in general. You may have heard of progressive web apps, which is extremely similar, not exactly the same. It's sort of built upon this idea of progressive web apps. And it leverages this thing called the Web App Manifest. The Web App Manifest is very similar to what we as Android developers think of as our Android manifest. It's a way of declaring resources and functionality that your app has. And this is from a website called Can I Use? It allows you to figure out whether or not you can, what features of the web you can use on which browsers. The ones for this specifically we care about are the mobile browsers. And you can see all four here, and then the line that's highlighted in black is sort of the current version. And so we can see this is actually not only supported on Chrome and the other browsers of Android, but it's supported on mobile Safari, iOS Safari. So this concept works on iOS as well. And it turns out that when you start looking at the web, and you start looking at functionality like this, where you can take what is otherwise a website that exists inside a browser and pull it out into what appears like a native app. When you start looking at the features and functionality that the web provides, it looks really similar to the kind of things we use as Android developers to build native apps. They have a concept called service workers, which are like background services. A background sync API, which is sort of like job schedule. It allows the app to actually run in the background while you don't have the tab open in a browser, or you don't have that web APK actually open in a PWA. It has notifications that can be shown to the user. It has a push API, which is like GCM or FCM, whatever it's called this month. Camera and microphone. Access the location of the device that's around it. We can draw GL to get graphics similar to games. You can actually get input from VR devices to get the 3D positioning that's required to actually do VR. And then Chrome is experimenting with ones that provide even more access to hardware, which is Bluetooth, where the web can interact with Bluetooth devices, and even USB. Actually, at Google, the way we flash builds of the Android operating system, pre-release ones, is through a website that uses ADB over web USB. All right, so the features are there of the web that bring them, at least the big ones, to parity with native apps. But are we really able to blur the line between, if we do this web APK install, can we really blur the line where we can fool the user to not really knowing the difference between these two things? I don't think that's true yet. There's two big problems with this. The one is how native apps are executed. We have this VM that chooses either an interpreter, a just-in-time compiler, or an ahead-of-time compiler to run the actual code. And those each talk to the CPU and execute the Dalvik bytecode that we have in our APKs. On the web, for something like Chrome, the majority of the runtime that's actually executing this is in V8, which is native code. So Art is doing very little. And V8 interacts with the file system where the actual JavaScript and HTML are cached. And then it only has an interpreter and just-in-time compiler, which talks to the CPU. So it can't do anything like ahead-of-time compilation. The other problem is JavaScript itself is a source-based language, which means it has to parse and interpret what you meant by the source code before it can even get to a representation that it can then compile to something more efficient. And on native, we get all kinds of little cheats that the web can't do. So for example, Art will take the just-in-time compiled or ahead-of-time compiled machine code and actually persist that back to disk. So the next time you launch the app, it doesn't have to do a bunch of work to recompile the bytecode into machine code. It can just load what it already did, and you get immediate, fast execution. If you've been hearing about what's going on in the web, there's an effort which is called WebAssembly, which is the idea of bringing bytecode to the web. Getting away from JavaScript, which is this, not only is it source-based, but it's kind of not that great of a language. And I think even most JavaScript developers will tell you this, although to their credit, the last few years, they've done an amazing job at iterating at this language. It just really has a lot of legacy baggage, and WebAssembly is a chance to not only push a reset button, but to bring things like performance where it otherwise wouldn't have existed. And so if we go back to when I was talking about Swift running on the web, the reason I said no is actually not because there's any technical limitation behind this. It's just that no one has written a WebAssembly converter for this yet. But it is technically possible, and there actually are efforts to do this. And so in theory, in the future, there should be nothing preventing you from taking that Swift code, compiling it to the WebAssembly bytecode, and then having that run in the browser. Same is true for Kotlin. So even though Kotlin JS is a thing, and you could target JavaScript, you can take the native Kotlin through Kotlin native and use WebAssembly to get the faster execution. And so this should speed up the web apps, the web in general, but also the web APKs that we've installed. compilation complexity becomes pushed to the developer instead of having to happen at runtime through interpretation. So that solves one of the problems that I believe is really holding back the true blurring of this line. But you still have the problem where, well, hold on. Okay. You still have the problem where this APK is not behaving the same as native in the sense that the runtime is different. And if we do this installation and look at what's inside this APK, we can open this in Android Studio, and you see that one of the cool things that we got for free is that when this APK is installed, it actually has an intent handler. And so from anywhere in the system, if you navigate to this URL, it'll actually launch the web APK installed app, which is a cool behavior where if the user goes and installs like the Twitter web APK and then click a Twitter link from a chat app, it won't launch the browser. This web APK will intercept it, and you'll get the native web experience. But elsewhere in the manifest, you see that, well, it's kind of hard to see, but there's the URL of the web app in here. And if you look into the bytecode of the main APK, you don't need to read it, but it pulls out this URL and then intents out to Chrome. And so what's happening is this web APK is really just like a jumping pad back into the old way that Chrome is rendering things. What I'd much rather see is this web APK that's being installed be brought like much closer to what a native app is, where inside the DEX file, it's a truly standalone system where maybe the V8 runtime is actually either shared or copied into this and executes natively in this process. There's huge advantages to be had here where you could leverage something like Job Scheduler to determine when the user has the screen off and the phone is charging, and you could do ahead of time compilation, where you could take that WebAssembly, run it through V8's compiler, turn it into machine code, and then persist it back in the application's cache folder. So when the user clicks that web APK the next time, it's actually just running machine code. I hadn't talked about this earlier, but permissions and notifications, those are features that are available on the web, but when you're running them in Chrome, Chrome becomes the app that's not only blamed for notifications and permissions when a website uses them perhaps improperly, but if you look throughout the system and try to disable notifications for a website, you have to do it through Chrome. You can't do it through the normal interface. You want to revoke a permission, you do it through Chrome, not through the normal interface. By having each web APK turn into a proper APK, those could be then blamed, not in a negative sense of the word, but maybe correlated or associated with the actual installed web APK instead of with Chrome. And yeah, JIT and AOT I talked about that. Okay, so I talked about a lot of different concepts here, and I want to really quickly try and paint a picture where I bring them all together. And I'm going to use Kotlin because Kotlin is like programming language Jesus for me. It's the one that I think you should be using, but really I don't care. If you're doing something like this, use whatever works, whether it's C, another language from a search engine company. But I'm going to pick Kotlin. Here's all the line draws, by the way. So in a modularized app where you have a bunch of common code, you have like your networking stuff, your database stuff, and in this Kotlin sense, it's written in Kotlin common modules that any part of any implementation can consume. And then maybe we write some like feature modules, which are the features that we actually want to show to our consumers of this app through whatever mechanism they're consuming it. Then those adapt these libraries into actual value propositions of the app. And then we want to come up with an Android client. So we adapt those 4 features into, say, Android UI. And then we create instant apps and what are they called? Android bundles out of each one so that they can be shipped in a bundle. And then we also create the module which does like the FAT APK for legacy users or users of app stores which are not Google Play. And so we get out an APK and we get out an app bundle of each individual feature. And then you're like, I want to write an iOS app. So I write an iOS set of features, which maybe adapt those and actually create the UI for iOS. And then we bring those all together and we spit out an IPA, which is the format for Apple apps. Then we also have the web, so we write the UI for the web. We pull those together and spit those out into our website. Then finally, we have like our backend, which is leveraging a bunch of the common modules as well for business logic. Then we get this world where, with whatever language you choose, there's a bunch of shared business logic. There's a bunch of shared features, and so the source of truth for this is always common. And yet, we have the ability to adapt that into what's native for the platform. But even doing this, while it looks pretty, especially with all those Kotlin logos on there, it's really not enough because we need to remember the other principles that we talked about, where every platform needs to be thinking in a responsive fashion, whether it's the Android app running on maybe a TV or a tablet, if Android tablets still exist, running on an iPad, running on an iPhone, running on a web browser, running on a TV, running on a web browser, running on a flip phone. We need all of these apps to adapt. And by thinking of them all with the same design system, that actually becomes really easy. And then finally, what's really cool about this, whether you use a single language, multiple languages to achieve this, is that no matter how the user gets into your system, they're treated with a really nice experience. And so if we just have Android in the web, they click a link, and maybe in some hypothetical future where instant apps and app bundles become married, they get a just-in-time APK spun specific for their device, and it all works. Or maybe they visit Google, what's this one? Or they visit Google Play, and they click install, and they get the same thing, but through a different onboarding experience. Non-Google Play App Store. Well, here they would get like the fat APK that you built. What's this one? Oh, the other one was a Play Store, but this one's Play Store, I guess. AAB. Chromebooks. Maybe they visit Google Play in a Chromebook. Well, now they get the APK with different architecture, with the different icons inside of it because the display is different. If they're still on a Chromebook and they visit through the web, maybe they can install the Chrome app version of your website. Or if they're just visiting inside Chrome with a link through from another website, they just navigate to the URL. If they're Chrome on the browser, they can then go through and install the web APK. Or if they're just getting a link, they can still follow the URL. And then we can't forget about our friends on the other side of the fence, which is if we spat out an IPA of this, we can get the native experience on iOS as well. If they're visiting through Safari, if they go to the URL, they can obviously still do that, but because the web app manifest is something supported by Safari, they can do their version of the web APK, which is the progressive web app that installed to their home screen and get the native-like experience. And then next year, in the hypothetical future of macOS 13, they'll be able to install that the native app, the native version of your app for iOS on their Mac. And then finally, if they're in an existing app and they hit a URL, like that app intents out to a URL or whatever the equivalent of intent is on iOS, they obviously still have the ability to fall back to the web. And these all interact, right? Like, so if you can bounce around between them, you can have upgrade experiences through them. But no matter what, your user is being served. And what's nice is that if you think about the two slides ago, they're all being served by the same, like backend in the sense of the word, that the code that backs it. And so if we can get to this point, regardless of the language that it's done in, if you can get the technology of how you build the app to the point where you can leverage that sharing to the ridiculous degree, if you can get the designers on your team to leverage the design system where it becomes not only consistent across platforms in the sense that your app looks and behaves the same, but it's responsive across platforms, and the idea that every platform needs to be responsive, and you can deploy these things to all the particular locations, you end up producing a really nice experience where it becomes irrelevant whether the user is experiencing your app through the web or through the native APK, because they truly shouldn't have to care. No matter how they get into your app's experience, they should have the best experience possible for that particular platform. And ideally, we can lose things like the giant banners that say, install the native app instead of visiting my website, which shouldn't actually matter because it's the same code, it's the same responsive design, and it's the same experience across every platform. And then, while this is painting a very pretty picture, there's a lot of work to get to this, but it feels more closer than ever. And so as long as we stay sort of vigilant about wanting to paint this future, hopefully we can get to the point where these lines truly are blurred. That's all I got. Thank you. All right.
So basically, what the guy is saying is that they want to be able to write something and then
Yeah, I don't think he's just talking about Kotlin though.
I think it's basically talking about, say, like rewriting that. Okay, we try to build like an agent app on the web now, and then using that same business logic, we don't have to write a PHP version, we don't have to write a Java version.